So we have here simulation analysis. Simulation analysis. So then to simulate, we need to understand from the word go that to simulate means what? Here to imitate reality. So to simulate is to imitate reality. To simulate is to imitate reality. To simulate is to imitate what here? Is to imitate reality. And in many cases will be forced to really imitate reality. So for example, if today you went to some driving school, good driving school, will they be able to give you a real vehicle? You go with this real vehicle to the road? No. They'll give you a toy. So you walk around with this toy on what we call a dummy roundabout. A dummy roundabout, use that toy in this case to learn. So you're simulating reality. If, for example, today you are to be a student studying medicine, there is no way anybody will take you to a physical person and then you start operating on them as you're learning. No. So first of all, they will give you actually animals like rats, cats. Yeah. You will have to start from somewhere. For purpose of learning, you'll be required here to do a lot of imitations for you to learn. The same case with pilots. You'll be taken to a room like this one, fitted here with some aeroplane engines, and you'll be told in this case to rev them around. And then you imagine like you're doing the real thing. Yeah, so imaginary. So you are imitating reality. Now, please listen. Whenever we talk of this simulation analysis, what are we supposed to be thinking about? If you look at the handout that I've just shared with you, I hope now at last you got it. So I would want you to look at number 2, simulation analysis, the Monte Carlo. It's called the Monte Carlo system. Yeah. So simulation uses computer generated random values. Computer-generated random values to simulate a range of possible outcomes. Don't write anything. Yeah, based on probability distributions. So the purpose here is to provide distribution of project outcomes. When we are simulating, for example, we make imitations and say that our selling price will be this much. So when we pick a selling price that is imaginary, what happens to our profitability? When we pick a variable cost which is imaginary, what happens in this case here to our profitability? So remember, we are using what this examiner has called computer-generated random numbers. Computer-generated random numbers. And this is where we begin our today's simulation class. So random numbers. Random numbers like that. And I would want us to take straight away exercises to understand how these random numbers work. And the exercise basically will be for us to know how we develop what we call the random number ranges. And I would want to start with exercise number 1. So for this exercise number 1, if, for example, you want to start a business today and you don't know exactly how much price you're going to charge. So you've done your survey around, then you realize that your neighbors are charging a price. Some of them are charging 10, your competitors. Others are charging 10, 20, others are charging 30. All right. And then we have our probabilities. Yeah. Probabilities are given. For example, this could be 0.3, this could be 0.2, and this 0.5. So this you must write. Random number ranges, we must write this down. Please try writing this down. This exercise, you must write them down. So you're doing exercise number 1. Exercise number 1. So please write down this very, very important question. You just write a title there. Random number. You don't have to put this S. It's random number ranges. Random number ranges, and then you start with exercise 1. Exercise 1, I want to start selling pens of this nature. And these pens, I'm not going to be the only person selling them in a market. We have other competitors. There are competitors who are selling pens of this nature for 10 bob. Others, they're selling for 20 bob. Others for 30 bob. And then we have been given probabilities. They've given us, whenever you see prob stands for probabilities. So in this case here, we are required to generate random number ranges. 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 Yes. I read the question, they want us to generate random number ranges. We generate random number ranges. So these random number ranges, what do we do with them? The random number ranges, the first thing that we will do is to ascertain what we call cumulative probabilities. Give us cumulative probabilities. That is the first thing that you do. You give us cumulative probabilities. So cumulative probabilities, what do? We add the probabilities downwards. We accumulate them downwards. We aggregate them. So in this case, cumulative probabilities, look at this. So then this will be 0.3. So you accumulate this here. You add this here. So 0.3 plus 0.2 gives me 0.5, right? And then we have 0.5 plus 0.5 because I'm accumulating, right? So that will be 1. But now again, remember that for random number ranges, we must always be consistent. We must always be consistent with our decimal places. So in the event that you have 1 decimal place, so everything here must be 1 decimal place, 1 decimal place. So I have to write 1.0 like that. So what have I done to accumulate? I've started here with 0.3 because of course the first one, nothing to be added there. So the first one, you will have here 0.3. You'll have there 0.3. So 0.3 plus 0.2, this gives us 0.5. 0.5 plus 0.5 gives us 1.0. Now from there, ladies and gentlemen, you'll be able to come and now give us what we call random number ranges. Give us random number ranges. So random number ranges, what do we have? Remember, these ranges begin from 0 to 9. They begin from 0 to 9. So this is when you have 1 decimal place. Whenever you have got 1 decimal place, we have here 0 to 9. If there were to be 2 decimal places, what do? 2 decimal places here, we say 00 to 99. You must write this as a note somewhere. And so forth. If there were to be 3 decimal places, you write 000 to 99, to 999, 3 of them. So generate random number ranges. Generate random number ranges. And the random number ranges shall be generating depends on the decimal places. When you have only 1 decimal place, then this is how the random number ranges will look like, 0 to 9. If there are 2 decimal places, we talk of 00, because there are 2 decimal places, 99. These are how many decimal places? 1. So look at what I will do to get my random number range for the first class. So the first class will be 0 all the way to the upper limit. Upper limit is 3. But to get, in this case here, the upper limit for the range, you take these 3 as if it's a whole number. You take these 3 as if it's a whole number, and then you take away 1. You deduct 1. So 3 minus 1, that gives me what here, somebody? Gives me 2. Please listen, and listen to me very well. I'll go to the next class. The next class now will begin from the next number after 2. Next number after 2 in my number line is 3. And then I come and write the upper limit. To get the upper limit, I will take this as if it's a whole number 5. And then I subtract what here? 1. It's a rule. So 5 minus 1, that gives me what here? That gives me 4. And then you take on the next class. The next class now will begin from the next number after 4. After 4 on the number line, the next number is 5. All the way to, you take this as if it is 10. So 10 minus 1, that gives me what here? 9. 10 minus 1 gives, you see, it's running from 0 to 9. Running from 0 to 9. Let me repeat this. How do we get these random number ranges? To get these random number ranges, ladies and gentlemen, you have to begin from 0. Then the upper limit. You read this from the cumulative probabilities as if it's a whole number. It's 3. And then to get that upper limit, we shall always take this number minus 1. So 3 minus 1 gives me 2. Then we go to the next class. You see, next class, I can't begin from 2. No. Next class, I'll begin from the next number after 2 on the number line. After 2, the next number will be 3. So right here 3 all the way to 5 minus 1, which gives me 4. Next number after 4 is what here? 5. 5 in this case here all the way to 10 minus 1. 10 minus 1 gives me what figure there? It gives me 9 like that. Great. So that's exercise number 1. So let me give you exercise number 2. Let me give you exercise number 2. Let me give you exercise number 2. Exercise number 2. So exercise number 2, ladies and gentlemen, I want to start in this case here, this business. But I mean, I don't know how much the rent will be. I don't know which space I'm going to take. So assuming I take a space that will cost me 10,000, 20,000, and then we have probabilities. So this is 0.40 and this is 0.60. Yeah, and then you're required in this case here to generate random number ranges. So required, generate random number ranges. Required, generate random number ranges. Very easy. Generate random number ranges. Generate random number ranges. Would you kindly try generating these random number ranges for us, please? Just try. The most important thing is for you to remember pretty fast that I can't generate random number ranges directly from probability. But first of all, there is need for what we call cumulative probabilities. So first of all, you have to do the accumulation. You must do the accumulation. So first of all, come here and accumulate this. So we have here cumulative probabilities. So cumulative probabilities we have here 0.40 and then you add, yeah, 0.40 and then we have here what here? Is there somebody who is able to see that in the cumulatives? Yeah. So remember now you can't tell me that this 0 here is irrelevant. That 0 there is very relevant. Yeah, it is 2 decimal places. Then could you kindly go ahead and in this case here define the random number ranges for me? So now remember, because there are 2 decimal, I have to talk of 0Z because there are 2 decimal places, so I use 2 digits. So 00 all the way up to 40 minus 1. Because now I read this as if it's 40, not 4. So 40 minus 1, that gives me 30. That gives me 39, isn't it? So that gives me 39. From there now we take on the next number. The next number after 39 will be 40. So I talk of 40 all the way to what year? To 99, isn't it? 40 to 99 like that. So 40 to 99. Anybody who has a question, remember if you have got questions, feel free to ask them. So then if you are comfortable up to here, please allow ourselves, in this case here, to go straight away to a past paper question. Let's go to a past paper question. And this past paper, it is in your notes. It is in your notes that I've given out today. Yeah. And I would want us to look, it's November 20, it's quite an old question. November 2016, question number 1B. November 2016, question number 1, boy. November 2016, question number 1, boy. It is there. It is there. So November 2016, question number 1, boy. SKB. Are we there? SKB. SKB is considering a proposal to manufacture a new drug named Millennium. The drug will be manufactured using a machine which will cost a whole 13 million. The cash flows and drug life relating to Millennium have been estimated as stochastic exogenous variables with the following distributions. So we have annual after-tax cash flows, probability, drug life, and then we have the probabilities there. So we have 2 variables there. And then they're telling us that the minimum required rate of return is 16%. All right. The company has approached you as a financial management expert to perform an analysis of the above project required. Using the following random numbers, perform 10 simulation runs of the net present value of this project. This is an examiner who is wishing you success. You'll be able to get all the marks. These are good examiners. Those examiners who are not sadists. Yeah, they wish you success. And there are not very many on earth. There are not very many on earth. There are not very many on earth. So, ladies and gentlemen, what I will do here. So first of all, you write down the variables. So the variables, we have in this case here, the annual cash flows. Write them down. So we have here the annual cash flows. So annual cash flows, I can see 1,000, 1,500, 1,000, 1,500, 2,000, 2,500, sorry, 3,000, 3,500, and then we have 4,000. And then we have probabilities. So our probabilities, I can see there 0.02. So 0.02. Then we have 0.03, 0.03. Then we have 0.15, 0.15. Then we have 0.15. Okay. Then after 0.15, we have 0.30, 0.30. Then we have 0.20, 0.20, 0.15, like that. So we have our probabilities. We have our probabilities. So you see, I've got two probabilities there. I have annual cash flows and I have drug life. I have drug life. So first of all, we shall assign random, because they want me to, if you look at the question, they want us to determine the following, using the following random numbers, perform 10 simulation runs. So to simulate, the first step will be for you to come here and they give us random number ranges. But how do I get random number ranges without cumulative? So first of all, we get the cumulative probabilities. So go ahead and give me the cumulative probabilities. Go ahead and give me the cumulative probabilities. So we have 0.02. If you add this one here, it is 0.05. So this will be 0.20. Yeah, 0.20. You keep on adding, keep on adding. You keep on adding downwards. And then remember, consistency is key here. Consistency is key here. Consistency is key here. Don't forget that. Consistency is key. Okay, so the next one here, it will be 0.35, 0.65. If you add this, it is 0.80, 0.85, sorry. Then we have 1.00. Please mark by last number. It is not just one. It has to be 2 decimal places. So it will be 1.00. It will be 1.00. 1.00. Now, after getting the cumulatives, then I'll be able to come and give you guys the random number ranges, which I would want to give you exactly 1 minute. Try deriving them on your own. These random number ranges, try deriving them on your own. Try deriving them on your own under device. Try running them on your own. So now remember, we have got 2 decimal places. With the 2 decimal places, what do we do? With the 2 decimal places, what do we do? With the 2 decimal places, what shall we do? With 2 decimal places, what shall we do? So random number ranges. So we have here 00. I'm alone. I feel like I'm alone. 00 to what here? Somebody please tell me the first class. 002. Thank you so much, Margaret. You must be a very good student. So 002, you know, I can't just write 1. And I can't write 10 for them to be 2 digits. So it is 00201, isn't it? The next class will be 02 to 04. Then we have 05 to 19, 20 to 34, 35 to 64, 65 to 84, 85 to 99, like that. So that is the first variable. That is the first variable, which is influencing. Yeah. So from there, ladies and gentlemen, go ahead and give us the drug life. This is another variable there, independent variable. So drug life. So you bring drug life, and then of course you give us cumulative probabilities given there, or that which you will be able to ascertain from the probabilities given, and then you give us random number ranges. You give us random number ranges. So the drug life, what do we have here? Drug life, my good students. Drug life, I can see the drug life. This is coming in terms of NOI. This coming in terms of number of years. So this is coming in terms of number of years. Drug life, I can see 3, 4, 5, 6, 7, 8, 9, 10. So I can see 3, 4, 5, 6, 7, 8, 9, 10. Yeah, versus the probabilities that they have given us. So probabilities that we have there. So I can see 0.05. I can see 0.10. I can see 0.30. After that, I can see 0.25. After that, I can see 0.15 again. Copy my figures at your own risk. 0.15. After that, I can see 0.10. After that, I can see 0.03, 0.03, and then 0.02. So once you've been able to get probabilities, go ahead and give us cumulative probabilities. Go ahead and give us cumulative probabilities as usual. So this will be 0.05, 0.15. I know now you're experts, eh? It's about adding downwards. So this gives us 0.45. This gives us 0.70, 0.85, 0.95, 0.98, 1.00. And then now out of this, we shall be able to get the random number ranges. Out of this, we shall be able to get the random number ranges. Out of this, we shall be able to get the random number. Out of this, we shall be able to get the random number ranges. Very easy. 00 to 04. 05 to 14. 15 to 44. 45 to 69. 70 to 84. 85 to 94. 95 to 97. Then we have 98 to 99. The moment you understand how to range, how to come up with these ranges, then automatically you have known like 100% of this concept of simulation analysis. We'll have known quite a lot. Thank you so much again, Margaret. I can see you went ahead to give me correct answers. So up to here, my physical students, are we really okay? My physical students up to here, somehow, are we okay? Great. Thank you so much. Thank you so much. Now from there, you'll be able to now go and prepare the last thing, which is known as a simulation worksheet. So give us a simulation worksheet. Give us a simulation worksheet. Simulation worksheet. Let me write it down here. A simulation worksheet. So this simulation worksheet, you shall start here with run number. So we have here run number. So number 1, 2, 3, 4, 5, 6, 7, 8. They have told us to run how many times? 10 times. They have told us to run 10 times. They have told us to run 10 times. Yeah. So remember, each run, you must predict our variables. For each run, you must predict our variables. We have 2 variables. So for each variable to be predicted, you use what we call random number. So you pick a random number to be able to predict cash flow. So that's the first variable. The second variable, you pick a random number. And then you will be able to get what we call drag life. You get what we call drag life. Like that. So remember, this Rn stands for random number. The Rn here stands for random number. Rn there stands for random number. Random number. Random number. And random numbers will be given to you by the examiner. And if you look at the question that we have, my friends, the question that we are doing here, you can see, ladies and gentlemen, that these particular ninjas have given me random numbers. You can see in the requirement, in the required, they've told me using the following random numbers. Using the following random numbers. So the random numbers have been given. Let me give you a minute first. Let me give you a minute. Yeah, for you to finish nicely. Finish nicely. There's no hurry in Africa. In Africa, there is no hurry. Using the following random numbers, do a simulation. Do a simulation analysis. Do a simulation analysis. Using the following random numbers, do the following. Yeah, do the simulation. All right, so we start. So you can see the first random number given there is 53 something. The first random number given there is 53 something. Now you can see it is 5397. This is a number which has been given there, so huge, 5397. This is a number given there, 5397. 5397. You see, this 5397 is 4 decimal places. It's 4 digits. And the 4 digits for sure, they cannot fit. 4 digits, they cannot fit. You can't fit them anywhere here. These are 2 digits. So what we're supposed to do is to come and dissect this. Yeah, we subdivide this into 2 digits. Because you remember our decimal places were 2, and here we have 2D to 2. So, and remember, we are doing one run until we complete. So it means that this random number here will be for this 153, and then next is 90 what here. Don't write them downwards. Are you able to see 5397? It's given down there. And we need how many digits at the same time? 2. Because this was a 2 decimal place question. It was a 2 decimal place question. So you subdivide this. It looks block, but you see there is no way 4 can fit. Yeah, at least 53 in the annual cash flow, I can see where 53 is. I can see 53 is here. Then I'll be able to pick a cash flow. But 5397 cannot fit. So I have to divide this into 2. Yeah, 20 pole. Now, what you're supposed to do in an exam is, first of all, to write all the random numbers. Go and pick the second random number given there. Actually, pick the next random number given there. The block random number given there. The block random number given there. Is there somebody who is able to see 6699? Yeah, so you write here 6699. Now you guys are young. You should be able to give me the other random numbers pretty fast. I write them. So they're telling me that the next one should be 3081. The next one should be 3081. Is that okay? So we have here 3081. They're not following. 1909. 1909. Yes. 3167. 81. 70. 38. 48. 83. Yes. 90. 13. 33. 58. And they told us to do only 10 runs. In the question, they told us to do 10 runs. 10 runs. So please write up to here. I would want to know whether the online students, are we together up to here really? The online students, by any chance, are we together up to here? Great, great, great. Great. The online students have confirmed that Mwalimu, up to here, we are together. So now let's fix the figures. Let's fix the figures. Let's fix the possible annual cash flows. Let's fix them. Like, for example, in the annual cash flows, when we have 53, where is 53 here? 53 is in this class, which corresponds to what cash flow, somebody? 3,000, isn't it? So when the random number is 53, when the random number is 53, 53 is not here, is not here. It is in between here, which corresponds to 3,000. How about 66? Where is 66? It is here. This corresponds to what here? 3,500. So could you kindly fill all your cash flows, please? Fill all your cash flows, please. Fill all your cash flows, please. Fill all your cash flows, please. Fill all of them, please. Please, fill all of them. And if you have a question, don't hesitate. Please ask. And of course, once you finish, if you are online students, there's a place there you can just type Y for yes. There's a place we will type there Y for yes. So have they finished those figures? Yes. So for the cash flows, when it's 30, 30 is here, 2,500. When it's 19, 19 is here, 2,000. 31, 31 is here, 2,500. 81, 81 is here, 3,500. 38, 38 is here, 3,000. 48, 48 is here, yeah, 3,000. 90, 90 is here, 4,000, eh? And then 58, 3,000. Thank you very much. How about these drug lives, shelf lives? 97. Another drug life now. So where is 97 here? How many years? 9 years, yes. So have you already finished this column? Have they finished this column? Thank you, James. Thank you, Lincoln. Thank you. Yeah, those are the ones who said yes. They're okay. I hope the other ninjas are okay as well. I hope the other ninjas are okay as well. I hope the other ninjas are okay as well. Is it okay? So 99 drug life gives us our 10 years. So this gives us 10 years. So this is 7, 4, 6, 7, 7, 7, 5. So the students who are with me here physically have been able to get these figures correctly. How about the online warriors, the ninjas? Are we together, the ninjas? Thank you. 97 ni 9. Unasema 97 ni 9. Ni ukweli, eh? Are all these figures correct, you people? They are correct, eh? 97 and 9. Yes, 97 uko juu ni 9. 97. It's 9 there. Now, come here and give me the discount factors. Now, I want to get NPV, remember. So I want to get net present value. So come here and give me what we call the discount factors. So do you know the cost of capital in this question? Have they given us the cost of capital? 13%. Now, let me ask you this question. Are we going to use PVF or PVFA? Atapotea in this question. Are we going to use PVFA or PVF? PVFA or PVF? Patapotea. Hata kikosea, so what? This is not an exam. It's not an exam. PVFA or PVF? PVF. Because the cash flows here are different. They're changing, right? No, you're wrong. You're wrong. Let me look at what these online ninjas are telling me. PVF, I'm a PVFA. They chose to be quiet, which is a worse evil. Now, remember, they have told us themselves that the cash flows that we have here are annual. Whenever you see the word annual cash flows, it means what? A repetitive. And remember, we normally look at one run at a time. So when we look at run number 1, we are assuming like the other runs are not there totally. So it's run number 1. And if it's run number 1, annually we shall get 3,000 for how many years? 9 years. Every year for 9 years. So basically here, discount factor, you will use in this case here PVFA. Yeah, 9. What percentage you told me? 13%. 10 or 16. You're the one who told me 13. We shall overcome. Initial cost is the one that is 13. Okay, then. No, I wanted to get the required return, which is 16. Thank you for that correction. 16%. So one thing that you're supposed to learn is that whenever we are looking at run number 1, we shall assume that the other runs are not there because they are mutually exclusive. Yeah, these runs, they can't exist like 2 of them at the same time. It'll either be run 1, where we enjoy 3,000 every year for 10 years, 9 years, I mean. And you see this word annual, I'm not the one who kept it there. If you look at their initial question title there, it has the word annual cash flow. It is there. It is there. So it's an annuity. It's an annuity. Haya, kuja hapa, kwa sasa itakuwa PVFA, 10 years. Wata wajaona nimetoa 10 years. Wapi hawajaona. The drug life, yeah. I'll be able to show you where we're getting the drug life. So remember drug life, first of all, we have these random numbers. So this 97 random number, where does it lie in this drug life ranges? It lies here, 97, which was giving us 9 years. I hope you are able to remember how we got the random numbers. So you look at 99, 99 is here. So 10 years and so forth. And so forth. So then here, you'll be required to come and pick PVFA. Yeah, 7, 16% is common. PVFA 4, 16%. PVFA 6, 16%. PVFA 7, 16%. PVFA 7, 16%. PVFA 7, 16%. PVFA 5, 16%. PVFA 6, 16%. So of course, for those of you who have got discounting tables, you can easily read them. But for now, I want you to use calculators to give me these answers. I want you to use calculators to give me these answers. Yeah, like what I'll do if I'm the one doing this, I will say PV far equals, like the first one, it will be 1 minus 1.16 raised to negative 9 equals whatever I get, I divide by 0.16. I write 4 decimal places. I'll take you slowly here because everybody must understand this. Everybody must understand this. Everyone must understand this. Everyone must understand this. I hope you remember the formula. I hope you remember the formula for getting PV farm. I hope you remember the formula for getting PV farm. I hope you remember the formula for getting PV farm. So the formula for getting PV farm, it is 1 minus 1 plus R. Yeah, all over R. So it will be 1 minus, like the first one. Yeah, 1 minus 1 plus 0.16 raised to negative number 9. Because you're talking of 9 years. Whatever answer I get, I divide by R, which is 0.16. And then I write a figure. So we have here number 1. Yeah, number 2, number 3. My table is not enough there. 5, 6, 7, 8, 9, 10. Yeah. I would have continued with my table, but it's not enough. It's not big enough. It's not big enough. It's not big enough. So discount factors, the PV first. So is there somebody who is able to give me the first one, 9 years, 16%? Somebody who can give me the first one, 9, 16%. Yeah, please, 4 decimal places, remember. 4 decimal places, remember. I will give you 3 minutes. Try to get all of them as you discuss between yourselves. Of course, you can read this from the tables, but what I normally do at this level, I just want us to calculate things from first principles. Thank you, Lincoln. Great. Okay, so Lincoln has given me this 4.65. The first one, is there somebody who is able to get that number? 4.65. How about the second one? 4.8332. Yeah, thank you so much. Please continue like that. I write the third one. Third one is 4.04. 4.03. Thank you so much. The fourth one, 2.79. Thank you. Continue. 3.6. 847. 4.3. 857. The same. 857. 4.3. 857. 6.1. 1. 7.1. The last one. 3.6847. Please check your number 9. Your number 9. Because you see, this is 5 years. Number 9. Check your number 9 again. 3.2. 7.43. Now, having gotten this, now you can come and do the last column, which is the column of net present value. You can come and do the last column, which is the column of net present value. The last column. And what do we do now here? You can see run number 1. We shall be enjoying a cash flow of 3,000 per annum, isn't it? Times, in this case here, this PV FAR minus initial outlay. Initial outlay, you give me a figure of 13,000. 13 million. But you remember your cash flows are chopped 3 zeros from them. Yeah, your cash flows are in shillings thousands. If you look at the question, your cash flows are in shillings thousands. So if you look at your cash flows, they are in shillings thousands. So meaning that even this initial outlay, you must chop 3 zeros. So Lincoln is not agreeing with all these figures. Lincoln, are these figures correct? All of them? Check them again. Are they correct? All of them? Lincoln, check them out. Now they are correct. So I'm discounting this. For run number 1, I'm discounting the 3,000 times this PV FAR that you guys now have, which will be 3,000 times 4.6065 minus 13,000. So remember, this will be in shillings what here? Thousands. Don't forget to chop 3 zeros from 13 million. Don't forget to do that. Don't forget to do that. So then are you able to give me an answer? 6 to 8. Lincoln is insisting that 6 to 8 is 4.038. Oh, Margaret. They are saying this figure is not right. This one here. Number 6 to 8. 8. 4.0. 4.0. Just check again. Yeah, 386. You can repeat. 4.0386. 0386. 38. Yeah, 38. Check again. That after 5, the number coming up is bigger than 5. So we round upwards 6 years. So then I've given you an idea now. So now you need to run with the ball and get all the net present values now. So run with this ball, get all the net present values. So now are you able to give me this first net present value? Fortunately, this question never had what here. Fortunately, it doesn't have. Fortunately, it doesn't have a scrap value. No scrap value, fortunately, no scrap value. What figure are you getting? The first one. Somebody give me this figure, please. So 3,000 times the discount factor minus 13,000. Yeah, minus 13,000. Now the online students are not even giving me. They're not giving me answers. The online students are not even giving me any answer. Unfortunately, they are not giving me answers, unfortunately. So what figure are we getting here? 3,000 times 4.6065. Are you getting a funny figure? My online ninjas are getting 819.5. Is that okay? Yeah. So you got the second one. The second one I can see it's 3,500 every year times the discounting factor, which is 4.8332 minus this 13,000 is common across. 13,000 doesn't vary, yeah? 13,000, that remains like that throughout. That remains like that throughout. That remains like that throughout. According to Lincoln, we are getting 3916.2. 3916.2. 3916.2. From there, we have a third one. So 2,500 times 4386 decimal minus 13,000, which will end up giving us what figure? The third one. How I wish I had a ninja who can just give me all the numbers. So according to Lincoln, it's minus 2903.5. All right. So we're almost there. The next one is 2,000, cash flow of 2,000 times 2.7982 minus that 13,000. So according to Lincoln, we are getting negative 7403.6. Is that okay? So we go to number 5. So number 5, I can see it is 2,500. So times this. So I believe now you have gotten an idea. And I know now you can give me all the answers now, all of them. I know now you can give me all the answers, all of them. I know now you can give me all the answers, all of them. Minus 3788.25 minus 3788.25. Come to the next one. The next one, what do we have here? $1135.1. Thank you. Minus 884.2. Thank you. Minus 884.2 again. Thank you so much. 84.2. Great. I wish we had that again. We finish. 97.2. 90? They're getting 97.2. Check. Check. But 96 is equally close. I would give you all the marks. Negative 1945. Negative 1945.9. So give me total net present value. Give me the total net present value. So you add all of them. You add all the NPVs to give us the total net present value. You add all of them. You add all of them to give us the total net present value. You add all of them to give us the total net present value. So one total net present value, you add all of them. So this is 819.5 plus 3916.2 minus this 2903.5 minus this, minus that, plus that, minus that, minus that, plus that, minus that. You give me the total net present value. So according to this ninja called Lincoln, I don't know whether somebody else is able to confirm the same, but according to him, the total NPV will be negative 11,841, negative 11,841.65. Once I get this, I'll be able to get what we call average NPV, which will be this divided by number of runs. Number of runs were 10. Divided by 10 runs. Divided by 10 runs. So then this one will end up giving us minus 11,844.165, and therefore project not viable. Project not viable. The project is not viable. Otherwise, I'll take this opportunity to thank you so much for having attended this session. It's my hope and belief you're not going out of this place empty-handed. You've gotten something that will be able to assist us even as we prepare for the December exams. Now, these physical students, of course, they're fine. Online students, should I be sending this link to your class? Do you think this class is worth it? Is it worth it? Is it worth it? I'm only getting very few responses here. So I will. Yeah, AFM evening group, yes, I will then be sending. Thank you so much. And please don't forget to read some of those small things that I normally share with you here. Like in this handout, you can see, yeah, you'll always get them in your theories. In this very same handout, you can see in this same very handout here, yeah, where they're discussing something to do with the advantages of simulation. Yeah, like it models real world variability, provides detailed probability distributions of net present value, many NPVs, many scenarios. Limitations, it is data intensive. Like I'm so sure you guys have hated the method, not because it's hard, but it's very, very involving. Yeah, it requires software and expertise. That's another disadvantage or a limitation. So see you tomorrow for advanced management accounting. Bye. Yeah, you'll get all these handouts right now. Give me just a minute right now. Bye-bye.